heart is a muscular organ consisting of 4 chambers. The walls of these chambers are composed of 3 layers. The thin outer layer is the epicardium. The inner layer, also thin, is the endocardium and is in direct contact with the blood. Between these two lies the main mass of the wall, the muscular contractile myocardium. The primordia of all 3 layers first appear early in the 3rd week after fertilization. The cardiogenic area is in the anterior part of the embryonic disc. The splantopleuric mesoderm in this area will give rise to the epimyocardial mantle, which differentiates later on into epicardium and myocardium. Between this mesoderm and the underlying endoderm is the mesenchymal network of cells from which the endocardium will be derived. As the body of the embryo folds together, the 2 branches of the network meet ventrad to the gut and finally fuse. The development of the endocardium from a double to a single tube can best be seen from a ventral aspect. At the earliest stage, the network of endocardial tissue is roughly horseshoe-shaped, the branches extending back on either side of the gut. The paired dorsal aortas are also plexiform at this early stage. The irregular clusters of mesenchymal cells quickly become organized into 2 strands, each of which develops a single lumen. At the cephalic end, they connect with the dorsal aortas. At the caudal end, they are continuous with the omphalomesenteric or VITELLINE veins of the yolk sac. Both atrium and sinus venosus will develop from specialized parts of this VITELLINE plexus. As the body folds together, the tubes meet and begin to fuse near the aortas. Fusion progresses caudally until, near the end of the 3rd week, the endocardium is a single thin-walled tube, except in the region of the sinus venosus. This tube elongates and begins to bend ventrally and toward the right. The ventricles will develop from the most sharply bent portion. The sinus venosus is now draining fluid containing some blood cells from 3 pairs of vessels. In addition to the VITELLINE veins, the plexiform primordia of the umbilical and common cardinal veins have appeared. The common cardinals will soon become the ducts of Cuvier. Just above the sinus venosus is the area of the primitive atrium. Cephalad to the ventricular area is the conus, leading into the truncus arteriosus, and thence into the well-developed first aortic arches. In less than 7 days, the endocardium has developed from disorganized clusters of cells into a single tube which will form the 4 heart cavities. Meanwhile, at about the middle of this week of development, the splantopleuric mesoderm has differentiated into epimyocardial mantles around the paired endocardial tubes. Epimyocardium and endocardium are separated by loose reticulum. The 2 heart tubes have been brought together by the folding of the body, and the foregut now passes dorsal to them. As development continues with fusion of the heart tubes, it can be seen that the heart is growing faster than the pericardial coelom, causing the now single tube to bend conspicuously. By the end of the week, there are enough specialized cells in the epimyocardial layer to produce a noticeable twitching movement, but this will not be sufficiently regular or strong to propel blood for several more days. The heart tube is now attached only to the aortic arches cephalically and the great veins dorsally. The way in which it becomes thus detached along the major portion of its length is best seen from the dorsal aspect. As the 2 halves of the epimyocardial mantle surrounded the endocardial tube, they fused ventrally but remained nearly contiguous dorsally as a dorsal mesocardium. As development proceeds, the mesocardium becomes fenestrated and by the end of the week has almost entirely disappeared, leaving a dorsal passage behind the heart which will be known later as the transverse sinus of the pericardium. During the next few weeks, the heart is involved in 4 separate shifts of position in relation to the embryo as a whole. The first is due to the forward growth of the head folds. In pre-somite stages, the pericardial cavity is caudal to the septum transversum and ventrocephalic to the buccopharyngeal membrane. As the head folds grow, the cavity and enclosed heart are rotated a full 180 degrees, ending caudal to the buccopharyngeal membrane and ventral to the foregut. The septum transversum is now caudal-ventral to them. The second shift is caused by the changes in curvature of the growing body and by the more rapid development of the cephalic end. In order to maintain a so-called front view of the heart in the animation to follow, it will be necessary constantly to change the angle of view in relation to the embryo. The third and fourth shifts are due to the growth of the liver. The heart rotates, bringing the right half toward the front, and at the same time, the caudal end moves upward. By the 22nd day, the epimyocardium nearly fills the pericardial cavity. The bulboventricular loop is deepening to form the left bulboventricular sulcus. The first aortic arches are declining, and the second are fully developed. By the middle of the fourth week, the third aortic arches are well developed. The myoendocardial space is filled with a homogeneous, transparent jelly which acts as a cushion, across which contractions of the myocardium compress the endocardial lumen. The heart tube is now filled with plasma and blood cells, and the myogenic contractions have become sufficiently strong, rhythmic, and peristaltic to circulate the blood through the chorionic villi, the yolk sac, and all the tissues of the embryo. Within the heart, the flow of blood is still undivided from sinus venosus to aortic sac. The ventricular portion of the bulboventricular loop now develops right and left bulges. The atrium migrates to a position higher than that of the ventricle and bulges into pouch-like right and left chambers. The third aortic arches are now carrying most of the blood from the heart, and the fourth arches are just appearing. During the fourth week, the primordia of all four chambers of the heart have developed from the single tube. In the fifth week, the gelatinous reticulum between myocardium and endocardium disappears in the region of the atria, but it remains as a continuous sheath around the endocardium from the atrioventricular junction to the aortic sac. Here it stops abruptly. The fourth aortic arches are fully developed by the middle of the week. The sixth or pulmonary arches have appeared. The capacity of the ventricular sacs is increasing steadily. Since the myocardial pulsations spread in waves from the sinus region toward the aortic sac, the two ventricles do not contract simultaneously. Two distinct currents are thus created, which may be the beginning of the separation between pulmonary and aortic circulation. During the last part of the fifth week, the gelatinous reticulum between the ventricular myocardium and endocardium is reduced, and the wall of specialized myocardium thickens. This tissue is differentiating from the myogenic layer, which originally covered the whole primitive heart tube, and which still covers the endocardium of the atria. The embryo now measures about 8 millimeters, crown to rump. To see the heart from the front, the embryo's curvature must be straightened. By the beginning of the sixth week, separation of the truncus arteriosus into aortic and pulmonary channels has begun. The atria are still expanding transversely and are being grooved by the truncus. Ventral extensions are appearing, which will become the auricular appendages. By the end of the week, the third aortic arches have become the common carotids, and the left fourth arch is the definitive aorta. The external form of the heart is now fairly well established. During the seventh week, the aortic and pulmonary trunks become completely separated. The embryo now has a crown rump length of approximately 20 millimeters. During the eighth week, the heart achieves an external form quite similar to that at birth. In the 6 weeks of development just shown, the heart has grown in length from about half a millimeter to about 5 millimeters. Some of the most important aspects of the external development can be seen only from a dorsal view. At the beginning of the 4th week, the sinus venosus is collecting fluid from VITELLINE, umbilical, and common cardinal venous plexuses. Just above the sinus are the primitive paired atria, and beyond them is the looped primitive heart tube leading into the first aortic arches. The primitive atria soon fuse to become a single transversely dilated atrium. This is becoming freed from the septum transversum to lie in the pericardial cavity, dorsal to and slightly to the left of the bulboventricular loop. The sinus venosus is now well formed and begins to migrate toward the right. The second aortic arches develop and then decline, and by the middle of the week, the third arches are carrying a large portion of the burden. It is at this point that the heart has begun to beat with sufficient force to produce a regular flow of blood. Near the end of the week, the 4th pair of aortic arches appears. The atrial region is undergoing extensive transverse enlargement and is bulging into right and left pouches. The sinus venosus is being freed from the septum transversum and now has a single opening into the atria. The veins leading into the sinus venosus are now well-developed vessels, and changes in them during the 5th and 6th weeks are understood more clearly if the hepatic circulation is also shown. At about the middle of the 5th week, a branched pulmonary vein arises from the plexus draining the newly formed lung buds. The 6th aortic or pulmonary arches are fully developed. Blood from the mesenteric part of the inferior vena cava is making a channel through the liver, and the venous wall is developing around it. This will be the hepatic part of the inferior vena cava. The upper portions of the umbilical veins are declining, while their branches, which connect with the VITELLINE plexus within the liver, are becoming major vessels. The one on the left is connecting with the ductus venosus. The right pulmonary arch is declining and will soon disappear. The superior vena cava is developing from the right duct of Cuvier. By the end of the 6th week, only superior and inferior venae cavae and the left duct of Cuvier open into the sinus venosus. The 2 branches of the pulmonary vein have been taken up by the wall of the expanding left atrium and now have separate orifices into it. The 3rd aortic arches are now the common carotids, and the left 4th arch is the definitive aortic arch. During the next 2 weeks, the superior vena cava migrates further upward and gains a separate entrance into the atrium. New tributaries to the left duct of Cuvier appear, but the vessel itself is receiving less and less blood from the cardinal veins and does not progress much further. By the end of the 8th week, it has lost all connection with the veins of the body and remains as the coronary sinus, draining the veins of the cardiac wall. The 2 primary branches of the pulmonary vein are now branched. By the 11th week, the 4 secondary branches have separate openings into the left atrium. At the time the heart begins to function as a muscular pump, it is still a single tube. Without any interruption in the current of blood it is pumping to the embryo, it must go through a complex series of internal alterations until it becomes an elaborately valved, 4-chambered organ. By the beginning of the 4th week, the endocardial tube is conspicuously bent. Dilatations are forming in the regions of the future sinus venosus, atrium, ventricle, bulbus cordis, and aortic sac. The portion of the bulbus cordis nearest the ventricle is the conus. The part nearest the aortic sac is the truncus arteriosus. Between the atrium and the ventricle is a slightly constricted area which will become the atrioventricular canal. By the middle of the week, the lumen of the truncus is slightly irregular in cross-section, giving the first suggestion of the division which will occur later. The walls of the ventricle have begun to thicken, and irregular branching bands of muscle tissue are beginning to protrude into the lumen. These are the trabeculae carni, and their growth requires a corresponding growth of endocardial tissue. The truncus begins to fold downward and toward the left, and both atrium and ventricle are developing right and left pouches. In the region of the atrium, the gelatinous reticulum between myocardium and endocardium has disappeared. The myocardium, though thin, has some contractile force. In the constricted area, which will become the atrioventricular canal, the reticulum is quite thick. It will form the endocardial cushions and is already acting as a primitive valve against backflow from the ventricle. The reticulum has almost disappeared in the ventricle. The myocardial wall here has considerable contractile force. In the bulbous cordus region, the reticulum is still thick and, here again, is acting as a valve against backflow. During the fourth week, the single endocardial tube has developed 4 distinct pouches which will become the 4 chambers of the heart. However, the blood is still flowing in a single stream from sinus venosus to aortic sac. During the first part of the 5th week, the shift in position due to the growth of the liver becomes noticeable. The right ventricular pouch is moving toward the left. The capacity of both ventricular pouches is increasing, and their contractions are favoring the formation of 2 separate streams within the flow of blood. At the same time, division of the truncus is beginning between the roots of the left fourth and pulmonary arches. The atrioventricular canal is dividing into 2 channels. Plastic masses of embryonal connective tissue are growing on dorsal and ventral sides of the canal. As these endocardial cushions bulge toward each other, they obliterate the central portion of the canal lumen. By the 6th week, separation of the truncus into aortic and pulmonary channels is well underway. It has now progressed to a point proximal to the semilunar valves, but the remainder of the heart tube is still undivided. Ventral extensions are appearing on the atrial pouches. They will become the auricular appendages. The heart has rotated toward the left. By turning it back to a frontal view, we can get a better look at the stage of development of some parts of the endocardial tube. The atrioventricular canal is now completely divided into right and left channels. Separation of both atrium and ventricle into right and left chambers is well advanced, and the primordia of the heart valves have appeared. In the 3 weeks of development just shown, the half-millimeter long endocardial tube has become a complex system of pouches and canals. It is about 2 millimeters in length, or roughly the size of the head of a common pin. The epimyocardial layers, especially around the ventricular pouches, are sufficiently thick to add nearly another millimeter to the total length of the heart. The embryo is about 13 millimeters long. Thus far, only the development of the heart wall and the vessels leading into it has been shown. It is now possible to observe formation of the septa and valves in some detail. Early in the 5th week, the atrium is bulging into 2 pouches. The gelatinous reticulum between endocardial and epimyocardial layers has almost disappeared, except near the atrioventricular canal. The myocardium has only a small amount of contractile force as yet. Near the center of the roof of the atrium, septum primum has just begun to develop, growing downward toward the atrioventricular canal. To the right of septum primum is the slit-like orifice of the sinus venosus. On either side of it are the valvulae venosi, which join at their upper ends and extend as a spurious septum on the roof of the atrium. The orifice between septum primum and the growing atrioventricular cushions is the primary interatrial foramen, or ostium primum. Near the end of the 5th week, a small opening becomes apparent to the left of septum primum. This is the orifice of the pulmonary vein. By the first part of the 6th week, the downward growth of septum primum has almost cut off communication between left and right atria. However, the cephalic part of the septum has failed to develop much in thickness, and a rupture now appears, which will become ostium secundum. Near the end of the week, the fusion of the atrioventricular cushions is complete, dividing the atrioventricular canal into right and left channels. At the same time, the free edge of septum primum reaches them and fuses with them. The line of junction is antero-posterior and slightly to the left of the midpoint of the cushions. By the time ostium primum has closed, ostium secundum is completely developed. There are now 2 pulmonary venous openings into the left atrium. This eventual transformation of one opening into 4 can best be seen in a combined sagittal and coronal section. As the atrium grows, its wall absorbs the proximal part of the vessel. When the first branching is reached, 2 openings result, and later on, these 2 are again divided. At about the middle of the 7th week, septum secundum begins to develop in 2 separate places to the right of septum primum. One portion appears on the anterior part of the atrial roof. The other appears more posteriorly and along the back wall. During the 8th week, the anterior and posterior portions fuse. The lower concave edge is directed caudally and somewhat ventrally. The cephalic part of septum primum is beginning to be resorbed, leaving the caudal part as a flap covering part of the lower edge of septum secundum. As the sinus venosus is incorporated into the atrium, the septum spurium ceases to develop and is resorbed into the growing atrial wall. In the adult, it will remain only as a low ridge, the crista terminalis. By the 9th week, the passage between the atria is an obliquely elongated cleft, the foramen ovale. By the 11th week, the sinus venosus is completely absorbed into the wall of the right atrium. Inferior and superior venae cavae and coronary sinus now have separate openings. By the 14th week, the lower edge of septum secundum overlaps the upper edge of septum primum, which is now acting as the valve of the foramen ovale. In the left atrium, there are 4 pulmonary venous openings. All of the internal structures of the atria are now completed. The next detailed development to be shown will involve the atrioventricular canals, their valves, and the interventricular septum. Early in the 5th week, a median ridge appears growing from the apex of the ventricular loop toward the atrioventricular canal. The canal itself is beginning to be divided into right and left channels by the growing dorsal and ventral endocardial cushions. The interventricular septum is now an antero-posterior muscular ridge. The crest of the septum was laid down first and is being added to from below as the ventricular pouches deepen. Thick, blunt flaps of connective tissue project from the endocardial cushions and from the outer walls of the atrioventricular canal into the ventricles. These are the primordia of the mitral and tricuspid valves. The canal is becoming a widening transverse slit. In the center, the endothelium is disappearing, allowing the cushions to fuse. By the middle of the 6th week, the canal is completely divided. The fused cushions continue to grow downward toward the interventricular septum. The right extremity of the cushions fuses with the posterior part of this septum. The anterior part of the septum is extending along the anterior wall of the ventricles toward the roof of the bulboventricular cavity. Toward the end of the 6th week, the free edge of interatrial septum primum reaches the atrioventricular cushions and fuses with them. The anterior part of the interventricular septum reaches the cushions at about the same time and fuses with them near the left atrioventricular orifice. The space which is now left between the septum and the cushions is the interventricular foramen. Its closure involves proliferations from both the endocardial cushions and the conus ridges. This can be understood better if the development of the conus ridges up to this point is observed first. The conus is the slightly wider section of the bulbous cordis where it joins the ventricle. Early in the 4th week, the bulbus is slightly irregular in cross-section, giving the first suggestion of the division to occur later. The gelatinous reticulum between endocardium and myocardium is thick and acts as a temporary valve. By the end of the week, subendocardial thickenings, similar in structure to the atrioventricular cushions, appear in the truncus. Blood is now circulating actively, and by the middle of the 5th week, the contractions of the two ventricular sacs are causing formation of two distinct currents within the bulbus. Pressure from the two currents causes expansion of the endothelial lumen of the conus into two channels. At the same time, the supporting reticulum fills in along the lines of less stress, forming two opposite ridges. Because of the relative positions of the ventricular sacs, the two currents tend to follow a spiral path up the bulbus. The ridges, therefore, also develop as opposing spirals. By the end of the 5th week, the ridges have begun to fuse in the distal part of the truncus. At the junction of the truncus and the conus, the primordia of the semilunar valves are appearing. Each ridge is developing two localized bulges of tissue. In addition, two other independent growth centers are appearing in opposite sides of the truncus wall. These are the dorsal and ventral intercalated valve swellings and will become the dorsal valve of the aorta and the ventral valve of the pulmonary artery, respectively. By the middle of the 6th week, the separation of aortic and pulmonary channels resulting from fusion of the spiral ridges has progressed back as far as the region of the valves. The valves are now plump swellings, and further formation may be influenced by the rapidly increasing back thrust of the systemic blood flow. In the latter half of the week, the conus ridges continue to grow toward each other. By the beginning of the 7th week, the conus ridges begin to take part in the closure of the interventricular foramen. Proliferation from the right conus ridge passes anterior to the right atrioventricular canal and fuses with the posterior edge of the interventricular septum. Proliferation from the left conus ridge fuses with the anterior edge and right side of the septum. Meanwhile, a proliferation of the atrioventricular cushions is fusing with the remaining free edge of the septum. The proliferations from the conus ridges meet and fuse, and the upper part of the foramen is closed. Tissue from the atrioventricular cushions continues to grow along the septum edge. It meets the lower margins of the conus ridge tissue and fuses with them, affecting final closure of the foramen. The part of the interventricular septum derived from these sources remains through life as a fibrous membrane. At this stage, the atrioventricular portion is at right angles to the interventricular part. Later, they will lie in the same plane. By the end of the 7th week, the semilunar valves have acquired increased definition and are cup-shaped. Due to the rotation of aortic and pulmonary channels from the 6th to 8th weeks, the dorsal valve of the aorta arrives in a dextral position, while the ventral valve of the pulmonary artery arrives in a sinistral position. Due to additional proliferation from the right conus ridge, the right atrioventricular valve now has 3 cusps and is therefore called the tricuspid valve. The left atrioventricular or mitral valve has no contribution from the ridges and is therefore bicuspid. The papillary muscles and the chordae tendineae are beginning to develop from trabeculae carneae in the vicinity of the atrioventricular valves. In less than 2 months of embryonic life, the heart, starting as a simple tube, pumping an undivided stream of blood, has become a 4-chambered, efficiently valved organ, pumping a pulmonary stream from the right side and a systemic stream from the left. Development from the 3rd month to term is primarily a matter of growth. At birth, the opening of the lungs results in the permanent closing of the foramen ovale, and with this final development, the structure of the heart is complete.